Okay, so this example is to horizontal projectiles. So we've got a particle projected horizontally at 25 meters per second from a point 78.4 meters above a horizontal surface. Find the time taken by the particle to reach the surface and the horizontal distance travelled in that time. So start by doing a little bit of a sketch of what's going on here. So you might want to just imagine that we're throwing something off a cliff here. So you've got this particle projected at 25 meters per second horizontally, and it's going to do something like this until it reaches the ground. And we were also told that it was a point 78.4 meters above the horizontal surface. We're saying that this distance is 78.4 meters. So when we're dealing with projectiles, we want to think about horizontal and vertical components of motion separately. So the key thing with a projectile, the only force that's acting on it is its weight. So if you imagine this particle, once it's been released, it's going through the air, it's moving everything, but there's no one pushing it still. That's already happened. The only force acting is its weight, so mg. So that means the acceleration is only in a vertical direction. There is no horizontal acceleration. That acceleration, of course, would be g, or 9.8 meters per second squared. So that's going to be the key thing for solving all of these problems, is just realising that when you resolve horizontally, the speed is constant. When you resolve vertically, the speed is subject to the acceleration of 9.8 meters per second squared downwards, and that's how we can approach things. So when we're talking about the time taken for the particle to reach the surface, it's really a case of thinking, right, well, for it to reach the surface, the vertical component of displacement must be minus 78.4 meters, because that's how far down it's gone. So I'm just using SY for the vertical component. If I wanted SX, then that's going to be the horizontal component. So we've got that. The acceleration is minus 9.8 meters per second squared. So because it's going downwards, that means that the acceleration is negative. The initial vertical velocity is 0 because it wasn't going up or down at that point, it was going horizontally. So we've got three things here. The thing we want to try and find is the time. Let's put AY by that so I'm clear on that. We want to find the time. So we've got three things. We want to find time. An equation that connects those would be S equals UT plus a half AT squared. So I need to substitute those in. So we've got minus 78.4 is equal to 0 plus a half of minus 9.8 T squared. Decimal points in the wrong place. So that's the same as saying minus 78.4 is equal to minus 4.9 T squared. And then I can just divide by minus 4.9 to get T squared equals 16. So T equals 4 seconds. And question B is about finding the horizontal distance travelled in that time. So again, if we start thinking about what we want, so we want to find a horizontal displacement, so that's what we're trying to find. We worked out the time before to be 4 seconds. We've got an acceleration of 0 because there is no horizontal acceleration, and we've got an initial horizontal velocity of 25. So we're actually going to use the same equation to connect all these, so it's still S equals UT add a half AT squared. So we're trying to find Sx, and that's just going to be 25 times 4 plus, well, 0 in fact. So in other words, we're going to get 100 meters for our answer.